September 2013, question 9, Black-Scholes method. A 1-year European call option on a non-dividend paying stock in a company ABC has a strike price of 150. The continuously compounded risk-free rate is 2% and the current stock price is 117.98. Assume that the market follows the assumptions of Black-Scholes model. An institutional investor holds delta H portfolio worth 100,000 call options to cash and short shares of a company ABC. Calculate the delta of the call option. So we need to calculate first and to calculate the delta of the backslash delta of portfolio is equals to backslash delta of call minus 100,000 into delta of call $10,000, 100,000 into delta of call minus 18673 delta of S. Okay, so this is there where obviously define delta underscore C is equal to delta of one call option and delta underscore S is equals to delta of 1 unit of stock. Okay, this is there. Next, since now we know since delta S just not delta S is equal to partial del S by del S, which is equals to 1, we get delta C is equal to 18673 into 1 divided by 100,000, which is equals to 0.18673. So this is equal to the delta of the call option. Number 2 was implied volatility of the underlying. So for the European call option we have this formula, backslash capital phi of D1, capital phi of D1 is equals to phi of ln of S underscore naught divided by K plus R plus half sigma square into T bracket close ln of S naught by K bracket close divided by sigma sqrt of T. Okay, so this is the ln of this phi of this entire thing, come out just of this. This is the phi of the entire thing, so therefore copying this, pasting and putting the values, which is equals to 117.98, K is equals to 150, R is 0.02, half sigma we need to take out, T is 1. So this is entire thing is equal to 0.18673. Now therefore ln of this entire portion is equals to phi to the power of minus 1 phi inverse 0.18673, so it equals to, that is equals to 0.89. okay, now 0.22012 plus 1 by 2 sigma square is equals to minus 0.89 sigma, so therefore this is equals to half sigma square plus 0.89 sigma minus 0.22012 is equals to 0. Solving this as sigma is equal to backslash quadratic is equals to minus 0.89 plus minus 0.89 square minus 4 into 0.5 into minus 0.22012 by 2n. By 2 into 0.5, and your so this is equals to 0.220. Therefore the implied volatility is 22%. okay, next is the price of a 1 year put and on the same stock with a strike price of 150. so using Black-Scholes formula, all equals to P underscore naught is equals to K e to the power minus RT backslash phi of D underscore 2 minus S naught slash phi and T underscore 1. okay, so 150 e to the power minus 0.02 backslash phi of 0 minus D underscore 2 5 minus G2 minus 117.98 backslash phi of D1. okay, where D underscore 1 is equals to ln of S naught by K. so I have this written, I will not write. ln of S naught by K is equal to this, so ln of 117, this was also there, so basically copying the entire portion only with only the volatility now known. so ln phi of 117.9150 plus 0.02 plus half into 0.22 square divided by 0.22, hence this is equals to minus 0.8095 8905. Okay, and alt equals to d2 is equals to d underscore 1 minus sigma backslash sqrt of t. So alt equals to minus 0.8905 minus 0.22 backslash of sqrt of 1, which is equals to minus 1.1105. Okay, and therefore alt equals to p underscore naught is equals to 150 e to the power minus 0.02 backslash phi of 1.1105 minus 117.98 backslash phi of 0.8905, which is equals to 31.45. And then calculate the investor retains their holding of 1 year put on the same stock with a strike price of 150. The investor retains their holding of call options and trader in the put and stock to achieve a delta and gamma. It should calculate the investor's new holding of the put and the stock. So now fourth part, alt equals to, we have delta c plus 0 is equal to backslash of delta p plus delta s. Doing this again, differentiating, taking partial differentials of the put call parity relationship. Okay, with respect to S naught. So doing this again, we have alt equals to backslash of gamma underscore c is equals to backslash of gamma underscore p plus gamma underscore s. Okay, is equal to 0 obviously. Then so the investor must have a short position in put options. So if x is the number of units of underscore p times backslash delta underscore s is equal to 0. So this is equal to 100,000 backslash of delta underscore c minus of delta underscore c minus 1 plus x is equal to 0. So X is equals to minus of 100,000. So the investor has a shorter loan. Holding of stock. Okay, so this is how you do a Black-Scholes sum.